Hello, and thank you for joining today. My name is Brian Randall, and I'm here from the outskirts of Tampa, Florida. I've spent the last 15 years as a sales engineer in the telecom industry. I'm currently pursuing my computer science degree at Florida State because I want to spend the second half of my professional career developing systems. From my work experience, I was familiar with the use of Erlang in developing real-time systems. At the beginning of this course, I was introduced to Prolog, which I found very intriguing. I chose this topic because I wanted to see just exactly how the variables of the logical language Prolog were incorporated into the functional language Erlang. Today, I'm going to be giving a brief history of Erlang, and then I'm going to be jumping into the similarities between Erlang variables and Prolog variables. Let's get started.
Erlang development commenced at the Ericsson Computer Science Lab in 1986. The goal was to design a concurrent system that would run, and I quote, forever. Telephony switches to this day need to be in operation continuously for incredibly long periods of time. A few developers at Ericsson were tasked with finding a way to build such systems. Their initial goal was not to design a new programming language, but to build a soft, real-time system. They started out using Smalltalk, but a coworker suggested that with what they were trying to do, Prolog might be better. As they started examining Prolog, they realized that they needed something more to support the concurrency needed in telephony systems. So the shift from Prolog to Erlang was driven by the need for a parallel system. However, some characteristics of Prolog remain even in today's Erlang. We're going to talk about those remaining characteristics as they apply to the variables in Erlang. Joe Armstrong, one of the initial developers of Erlang, stated in a 2007 speech that the remaining signs of the Prolog heritage lie in the syntax for atoms and variables, the scoping rules for variables, and the dynamic type system. We will examine these three elements in Erlang and Prolog in order to come to a conclusion about the similarities between Erlang variables and Prolog variables. So first, we will examine the syntax of Erlang and Prolog variables. In both languages, variable names must begin with a capital letter or an underscore. If the name does begin with an underscore, convention says that the next character should be an uppercase letter, but I found no syntactical requirement in either language. However, if the variable name does begin with an underscore, then it must be followed by at least one alphanumeric character. Erlang, for some reason that I could not determine, allows the use of the @ sign in variable names as long as it is not the first character of the variable name. Prolog does not allow the @ sign to be used anywhere in variable names. So let's try sending some similar commands to both Erlang and Prolog and just see the results for ourselves. So to demonstrate today, I'm going to be using SuperPuttee. SuperPuttee will allow me to put both shells into the same screen so that I can send one command up here, and over here on the left, this is my Erlang shell, and then over here on the right, this is my Prolog shell. So let's start with a variable name that, according to the syntax rules of both languages, should work with no problem. A variable name starting with an uppercase U, and we'll go ahead and try to bind it to a variable, or I'm sorry, to a value. Okay. In both shells, it looks like we have success. In Erlang, through pattern matching, which we'll talk about later, the value 1 was in fact bound to the variable with the name uppercase with an uppercase U. Over here in the Prolog shell, you can see that through unification, essentially the value 1 was bound to the variable uppercase. Now let's try one that shouldn't work. Let's see what happens. Let's try lowercase equals 1 with a L, lowercase l to begin the variable name. And yes, over here in Erlang, we get an exception error, and in Prolog, we get return the value false. So we can see that's exactly what we expected here. Now let's try one a little bit different. Let's try crazy, but instead of the A, we're going to use the @ symbol, and let's see what happens. Okay. So over here in Erlang, you can see that it basically, through pattern matching once again, value 1 is bound to the variable crazy with a @ symbol replacing the A. In Prolog, that things didn't happen quite so smoothly. We get a syntax error back, and as we suspected based on the documentation, the @ symbol is not allowed in variable names in Prolog. So there is one difference that we've come across. Now let's jump back over and let's take a look at scope and binding of the variables, and we'll look at those at both Erlang and Prolog and see how they compare. In Erlang, variables are local to a function clause. Thus, there's no real concept of global variables. This is similar to Prolog, where the scope of Prolog variables are limited to the clauses in which they appear. Erlang variables are described to be single assignment. That is, any variable in Erlang can only be assigned a value one time. A variable is either unbound or bound to a value that will be its permanent value. Prolog is similar, and its variables are often referred to as assign once variables. The difference in Prolog is that through backtracking, variables can actually be uninstantiated and then reinstantiated with a new value. Since Erlang is a functional language, there's no such concept as backtracking. So there really is no such manner in Erlang to get a variable to be uninstantiated. Erlang variables are bound in exactly one manner, through pattern matching. When a value or expression is a pattern match for a variable, then binding occurs. If a pattern match is attempted between a left-hand side that is a bound variable and a right-hand side that is not an equivalent to that bound variable, an error occurs. Prolog variables can be bound by either unification or use of the is operator. Unification uses the equal sign operator, so textually it actually appears to be the same as an Erlang pattern match. The Prolog is operator can be used to bind a numerical expression on the right-hand side to a variable on the left-hand side. There's no such equivalent in Erlang. Another difference is that because in Erlang we're using pattern matching, variable assignment is asymmetrical. However, in Prolog with unification, this assignment is actually symmetrical. Let's switch back over to SuperPutty, and we've gone over quite a few items here. Let's take a look at all of them and break them down and show you some examples. Okay, so I am back in SuperPutty here, and this time I'm just going to be working on the Erlang shell and for now, and just to show you some of the pattern matching aspects and some errors that can happen with there, specifically when it comes to the single assignment value of variables. So let me start off. Let me go ahead and bind the value of 1 with the variable x. And this is going to happen because of pattern matching, and we see a result there that it shows a success. Let's go ahead and now let's bind the value 2 with the variable y. Once again, we have some success. Okay, in many other languages, especially the procedural languages that a lot of us are used to, we could easily do a statement such as x equals y, and x would essentially become the the value of y. In Erlang, this is not possible. And we see that since y was a different value than x, and x was a bound value, we see that this just isn't a possible operation. Now to put it in perspective, let's make z is equal to 1. Okay, so now we see that the value 1 is bound to the variable z. Now let's try the same thing as previous. Instead of using y though, let's use z. And there we get 1. So because the values are the same, that is a valid pattern match. Okay, I'm going to go back to using both shells here. And we'd also talked about the is operator in Prolog and how we could not find that there was an equivalent in Erlang. So let's just try it out. Let's try I is 3. Let's see what happens. Okay, you can see over here in the Erlang shell that we do get a syntax error, while over here in the Prolog shell we see now that the value 3 is in fact bound to the variable I. We'd also talked about the asymmetrical aspect of Erlang variables and how we concluded that that wasn't exactly the same with Prolog, just because of the way that unification works in Prolog. So let's give it a shot. Put in here, let's do 4 equals a to test this out and see if we get the expected results. And sure enough, we get an error over here in Erlang that variable a is unbound. And over here in Prolog, meanwhile, we get that the value of 4 was in fact bound to the variable a. So the last characteristic that we needed to go over today was just the dynamic type and how that relates to the variables. And we've actually already seen this in our previous examples. As you saw me typing variables into both Erlang and Prolog shells, there was no requirement in either for me to first declare the variable or the type of the variable. So in this manner, the variables of Erlang and Prolog are once again similar. So to wrap everything up, we've basically seen that Erlang variables are in fact very similar to Prolog variables, which would make sense seeing how that's basically where they came from. Most of the differences we did uncover, such as the availability of the is operator for binding in Prolog, those were more of aspects of the language operation than the inherent characteristics of the variables themselves. The only real notable difference that we uncovered was the use of the @ symbol in Erlang variables, which, as we saw, produces a syntax error in Prolog. That wraps up our presentation for today. We thank you for joining and hope you learned something useful.